All right, so this is a PowerPoint program. Dennis has allowed me to have the option to share my screen, and I'm going to do that right now. And this program is about ready to get underway. Let me just go to slideshow, and we'll begin from the beginning, which is always a very good place to start. Now, we realize, of course, that, and by the way, before I begin, every so often I'm going to pause for 5 or 6 seconds because I'm going to take a swig. Since I'm going to be talking for the next hour or so, I'll take a swig of Poland spring water just to wet my whistle and to water down my throat here. But in any case, we realize, of course, that ever since mankind has walked the face of this planet, that he's gazed upward into these beautiful nighttime skies that sadly we so rarely see where we live. But he's enjoyed the sights. And in particular, he's been also able to look up into the sky and see a number of different things that have attracted his attention. In fact, it's been the way of the world ever since man started looking up at the sky, and all the way up to this day, that people who look up into the nighttime sky see something and want to share it with their companions. Oh, you should see what I saw last night. Oh, what was it? Where was it? Oh, I want to look at that. And by the way, the next time you look, I want you to look at something because I really found a marvelous object up there in the sky. And so we have gone about from one generation to another, looking up, staring up at the sky, and seeing magnificent sights to gaze upon, to study, to enjoy as we looked into the sky. And there are objects beyond our ability to count, I suppose. Some of them truly stand out. Of course, probably the first and most important is a star, our star, the sun. What a wonderful object. It's a tremendously hot ball of gas, as we all know. The 864,000 miles across is the part that we see. Normally, all gas from its surface to its center, gas clear into its entirely hot central regions, 11,000 degrees on the surface, over 30 million degrees at its center. Gas, nonetheless, all the way through. Gas so dense that the average weight of a small amount of it, a cubic centimeter of this, is heavier than the weight of an equal amount of water. The sun, compressed, hot, spewing out all forms of radiation out into space. And just check out some of the magnificent photos that we've been able to view through the courtesy of those who have gone beyond our atmosphere in some of the spacecraft that we now have. And look at that prominence that you see on your screens right now. That rising, now mind you now, the diameter of the sun is about a million miles, almost. Well, that thing must be spewing out or shooting out there 250,000 miles or more. That tongue of incandescent gas, the sun, that which provides all of the energy for all of the life that exists on our planet. And who possibly could not marvel at the spectacle of a total solar eclipse? No spectacle that nature has to offer can rival a total eclipse of the sun for sheer drama and excitement. It's not just something you see, it's something that, well, those of you who have been to a total eclipse realize that it is an experience. Every fiber of you becomes involved during those few precious moments of totality. And of course, at the beginning and at the end, we have those magnificently beautiful diamond ring effects that grace our skies. They are indelibly planted into our memories, and they remain a lifetime once we have been there in the path of the shadow of the moon as it sweeps across the surface of the earth. By the way, you may remember 5 years ago in 2017, we had what was referred to as the Great American Solar Eclipse, the first time in almost 100 years that the path of the moon shadow went from one coast across the United States to the other. If you were not in the totality zone then, you have another chance in about 2 years. Mark this on your calendar, write it down. make a mental note. Monday, April the 8th, 2024, the path of a total eclipse of the sun is going to sweep across upstate New York. Buffalo, Rochester, Syracuse, Plattsburgh, Watertown, all of those places upstate will be able to see the sun go into total eclipse, the skies plunged into darkness, stars and planets appearing in a daytime sky, a beautiful, spectacular sight. Now, you could stay here in New York and see a 92% partial eclipse. Don't do that. Go the few hours north on the Northway, Interstate 87, or up into northwestern parts of New York State to get into that zone of totality so that you too can see and enjoy a total solar eclipse. And of course, there are other things up there in the sky to enjoy. There are the planets, mighty Jupiter. Oh, we've been able to look at that now through photographs taken by spacecraft that have come up so close and have been able to get just magnificent views, not only of Jupiter itself and the clouds that stream across its surface, but also some of the amazing satellites that Jupiter possesses. And Mars. Oh, Mars. Right down through the ages. Mars, an exciting object because of its red color. Mars, then seen through the telescopes of Giovanni Schiaparelli back in 1877. Mars with those lineations called canali, translated from the Italian into the word canals. Something got lost in the translation. When Schiaparelli saw these lineations for himself, he was thinking about natural channels that were on the surface of Mars. But canals imply that somebody was up there, somebody who designed and actually dug and made those canals. Oh, intelligence on Mars, perhaps. This is an actual headline from the New York Times over 100 years ago. Somebody claiming that they would actually receive the reply via radio from the Martians up on Mars. Well, anyway, Mars from here on the Earth seems to go through a variety of different seasons. The polar caps near the poles grow during the Martian winter, then shrink during the summer, and apparently provide water to vegetation. See those areas of green on the surface. And the thought was that maybe life existed on the planet Mars. We've got to go there, said man. We've got to go there and find out what Mars is like. We have gone there. And instead of finding canals, instead of finding Martians, instead of finding vegetation, all we have found so far on Mars are nothing but rocks, a rocky, barren surface. And along with the planets, there are the constellations. For example, here's the Big Dipper, which I'm sure most of you recognize, 4 stars in the bowl, 3 stars in the handle. And if we use the 2 stars at the end of the bowl, Doobie and Merak, and if you remember, if you were a Boy Scout, a Girl Scout, a campfire girl, you remember that those are the 2 stars that if you stretch a line out in this direction, you come to a bright star. Not the brightest, but a reasonably bright star. And the most important star, that is Polaris. Polaris, the North Star, located at the end of the handle of the much fainter Little Dipper. There's the handle of the Little Dipper. There's the bowl of the Little Dipper here. Looks more like a meat cleaver as opposed to a dipper. So there's the Big Dipper and there's the Little Dipper. And there are other star patterns, constellations, we call them in the sky. Here is Gemini. Gemini are the twin brothers. This is Castor. That's the head of Castor here. He's the slightly younger brother as compared to his sibling Pollux, the older of the 2 twins. They are with holding hands, or they have their arms over their shoulders. Castor's the one with the short leg, and Pollux was the one with the long leg standing beside him. And here's a photograph that I took when I was in a very exotic land. I was on Easter Island. I'm sure all of you have heard of that, a little mysterious speck of land in the South Pacific Ocean. And I was there in April of 1986 to see a very famous celestial visitor, Halley's Comet. You see, Halley's Comet was best visible to the south of the equator in 1986. And so I led a tour group and we went to a very exotic land, Easter Island, to see Halley's Comet. And I took this photograph. This is a picture of the scorpion. The scorpion there. You could see the claws of the scorpion over here, going down to Antares, marking the heart of the scorpion. And here is the tail of the scorpion, ending in this pair of stars, marking the stinger of the scorpion. Oh, and by the way, in case you haven't noticed it, Halley's Comet is in this photograph too, right over here. In 1986, everybody thought that Halley was going to be putting on a great show if we headed south and went into the southern hemisphere. They thought it would be beautifully ornamented with a nice long tail. Instead, the comet, well, didn't live up to expectations and appeared as nothing more than a hazy blotch of light in the sky to the south of the scorpion's tail. Well, the nighttime sky from the southern hemisphere was very, very beautiful, and it more than made up for the lack of the spectacular view that we were expecting out of Halley's Comet. In fact, this part of the Milky Way, you see this hazy band over here in Scorpius, the Scorpion, and in the adjacent constellation of Sagittarius, is the most beautiful of all, the brightest of all. And the clouds of stars that exist above us. Every speck of light that you see in this picture is a sun, just like our own. And who knows whether or not any of these have circling around about it planets possibly to harbor life. The imagination goes on and on and on and on as we look into the sky. The color cameras enabling us to see things that the mind of man could only guess at before color photography came along. Now, here's a black and white photograph, and I'm going to show you the same object in living color. This is the North American Nebula. And indeed, it does look like North America, doesn't it? Here's Florida. Here's the Gulf of Mexico. Here is Mexico. And here's the west coast of North America, the west coast of the United States. And what a beautiful, beautiful sight it is in color. And again, what wonders we were able to see once we perfected color photography, astrophotography. And here is another beautiful object, the Pleiades, the seven sisters that are wrapped in veils of gossamer blue. You see the seven beautiful princesses, if you will, making up the Pleiades, the seven sisters. And it is also encompassed by other stars, many other stars in this star cluster, but the seven stars that you see here are the brightest. How many of you drive a Subaru? Do you know that Subaru in Japanese means Pleiades? And if you look at the insignia or the logo for Subaru, there indeed you see the stars that make up the Pleiades star cluster. You could see the Pleiades right now. Right now, it's a wintertime constellation. Actually, it's a wintertime star cluster in the constellation of Taurus the Bull. There you see the bull, the V-shaped face, the orange-red Aldebaran, the angry eye of the bull. And why is he so angry? Well, maybe we might consider the Pleiades not as seven sisters or seven princesses. Maybe we might consider them as seven bumblebees stinging the back of the bull. And maybe that's why the bull is so angry or so irritated. But you can see the Pleiades now. If you step outside 7, 8 o'clock at night, look high up into the sky and toward the south, you can't miss the Pleiades. The seven stars are so close together, they look like a fuzzy patch on the sky. Nothing else like them in the sky. And they are there for you to see and to look at and to enjoy on these cold winter nights. And there are also other objects. There are veils draped on through the stars, veils for the shoulders of a queen of the sky, or any other fair lady for that matter. Veils for their shoulders and rings for their fingers, and roses for their hair. A magnificent universe is ours. There are great lagoons in the sky through which mythical canoes can be paddled. Lagoons giving birth to stars in tomorrow's skies, and helixes twisting and turning. Stardust, every bit of it stardust, ashes of a star, blowing away the outer layers of itself out into space. There are owls lurking in the sky, and tarantulas creeping across the deep southern sky. Oh, even a dumbbell here and there. What beauty! What beauty! A sombrero to shield you from the searing rays of the sun by day, and whirlpools to catch you up and sweep you into your imagination, into the vastness of the universe that is yours. It's a magnificent sky. There are even quasars out there, recently discovered, sending forth radiations unbelievable in amount, and jets of gas rushing outward from them. Quasars, unknown. What can they be? We find them not with our eyes, but rather we find them with the great radio telescopes that gather in from space radio energy, similar to light energy, but different in wavelengths, gathering in that energy and then compacting and condensing these wavelengths into energy that causes it to activate a pen that moves up and down as a piece of paper passes beneath the pen. From space, scribblings, and the men of radio astronomy reading these messages from space, determining the nature of the sources of the object that have sent such radiations to us. Yes, wonders, wonders, wonders. But of all the great and wonderful objects that are out in space, what could we choose as the seven most remarkable objects, 7 objects that are attainable for us, either with the unaided eye or with small telescopes, 7 objects that could be called the 7 wonders of the universe. And first among these, and this is subjective, these, I mean, you could ask 7 other astronomers, you could ask any number of astronomers to list their 7 top objects in the sky. This is my list. This is, again, a highly subjective list. This is my list of the 7 wonders of the universe. And first on my list, the first on Joe Rayo's list, is the face of the moon. Oh, gaze upon the face of our natural satellite. The great dark regions, the Maria, the seas, we call them, though we know there's not one single drop of water there ever, the craters, the mountains, the rays streaming forth from some of the craters. Exciting, exciting, exciting. Close up, through the telescopes of man, we see the Sea of Rains. This is the Sea of Rains right here, Mare Imbrium. And over to the upper left of that region, a crescent-shaped domain of beauty. Sinus Iridum, Bay of Rainbows, one of the truly delightful objects to gaze through a telescope as we look to the moon. To the right of it, here's a crater with a very dark, smooth floor, named for Plato, the great philosopher. And straight to the south of it, another crater, again away from the mountains, but this time a crater with a very light grayish flat floor, the crater Archimedes. And as you go down to the south at the end of a chain of mountains, you see Eratosthenes with a mountain right in the middle of the crater. And all the way to the left of that, the monarch of the moon, Copernicus. Well, here again is Archimedes. And you see the rivers that may have been formed of liquid rock that may have been flowed when the moon was at a very early age. And you can see the other craters nearby and the mountains that are at the edges of the great seas. And now here it is, Copernicus, there at on the face of the moon, perhaps one of the most magnificent photos taken from this planet Earth toward our natural satellite, taken by the Lick Observatory out in California. And up to the upper right of it, you see Eratosthenes, and directly above Copernicus are the mountains of Gay-Lussac. And directly south of Copernicus, a little crater right here, looking like a keyhole, Fouth, a mile deep, Fouth. Oh, it's a wondrous part. And you see the streamers of brilliance that seem to radiate out from this crater in all directions. Beauty, the rays coming from the monarch of the moon. Then, of course, from our satellites that have orbited our natural satellites, looking downward above the crater Fouth and looking across that 65-mile wide basin with the mountains in the middle, to the terraced far walls, and to the mountains of Gay-Lussac far to the north, and then closer still, now looking directly above the rim of Copernicus crater, down into Copernicus, to those mountains over 5,000 feet tall in the middle, to the walls 10,000 feet in the distance, to the mountains another 10,000 feet. Photograph of the century, this one was once called. Photograph of the century. Ah, but the moon is a barren place. No bugs, no blade of grass, no sound, no air, no rain, no ice, no snow. Nothingness, nothingness, nothingness. And yet, ironically, that nothingness that is there, attracting the spirit of man like nothing else that has ever been, beckoning man, come to me, come to me, come to me. And man went. And most of you recall that, well, I don't know, most of you. You see, I to me, it was like a few years ago. It's hard for me to imagine or believe that it's now over 50 years ago. And maybe some of you are very young and were not around when this happened. But those of a certain age will always remember a very special Sunday night in midsummer in the year 1969, when all of us were glued to our television sets, and where just a few minutes before 11 o'clock Eastern Daylight Time on that incredible special night, we watched as a man climbed down a ladder, rung by rung, until the footprint of a human being was ultimately and finally pressed into the dust on the face of the moon. Man on the moon. Now consider this, that footprint that is there, still to this very day, unchanged, for there is nothing to remove it, nothing to change it, nothing to blow the dust away or to spoil it, unless perhaps on the slight possibility some strange erratic projectile from space were to crash down on that site and obliterate it. But consider that it could be 1,000,000 years from now, that footprint left behind by Neil Armstrong would be just as fresh as it was the day it first was planted there on the surface of the moon. So we went there, 12 all told, 12 Americans walking, cavorting on the face of the moon. 2 by 2 we came in our Apollo program. And they brought back, these 12 astronauts, moon rocks. Ha ha! Moon rocks filled with beauty. For the moon rocks, you see, containing among various ingredients, beautiful little beads of glass, baubles from the moon, beads that are red and golden, blue and black, crystal clear and yellow, every color of the rainbow. And where did they come from? You saw those rays extending out from the craters of the moon. Ha ha! Projectiles from space crashing into the rock of the moon. The heat of impact vaporizes that rock. Up it goes, and then finally condenses into liquid material, which forms a spherical shape, freezes immediately, they do, not into crystalline material, but as glass. Beautiful, tiny baubles of glass covering much of the surface of the moon, brought back here to Earth by the men of the space age for us Earthlings to enjoy. Yes, number one on Rayo's list of the 7 wonders of the universe, number one on our list is the face of the moon. I see somebody, Vincent Homerick, is raising a hand. Vincent, I'm going to answer all and every question after the talk. When I'm done with my talk, we'll have a 10 or 15 minute time frame for a question and answer period. So hold on to your thoughts, and I'll be back, and I will answer your question a bit later. Now, number 2 on Rayo's list is the rings of Saturn. Oh, I don't know how many of you have had an opportunity to see Saturn's rings in a small telescope, but I must tell you that if you have not had that pleasure, the next time you get a chance, please do yourself a favor and look. They seem to glow with an inner light. Of course, the rings are illuminated by the sun, and they are not solid disks as they appear, but rather particles of matter, at least 10 miles thick, and the particles from within reflecting sunlight, even as the particles from the surface do, causing this illusion of an inner glow as we gaze through our telescopes at these rings. Of course, the rings are not always visible to us, of course, because as we move in our orbit and Saturn and its around the sun, periodically we see the top part of the rings and the bottom half, and in between, there comes a period of time when the rings are edgewise to us. And so thin are they, almost 1 billion miles from us, that even in the biggest of telescopes, we can't see the rings readily because they are turned edgewise to us. You see the views, the changing views here. Very exciting, nonetheless, because when the rings are edgewise to us, then we get a chance to obtain photographs, good photographs from Earth of some of the satellites of Saturn. Here you see Saturn's rings turned edgewise, and this arrow is pointing to a new moon that was discovered back in 1966. That was number 10, Janus. And since then, we have discovered many, many, many more moons of Saturn. In fact, I think at last count, Saturn now has 78 moons. Most of them are very tiny and very small. Only a few, like the biggest moon of Saturn over here, Titan, which is even bigger than our own moon. But when the rings turn edgewise, then we get a chance to see or photograph better the various satellites that turn about Saturn. Now, in case you're wondering where to find Saturn, you can't, because right now Saturn, this is the way it was last summer in our evening sky, glowing beautifully in the southern part of the sky during the much of the night. But right now it's February, and right now in this same part of the sky, you know what's in the same part of the sky? The sun. And because the sun is in this area of the sky, we can't see Saturn at all. The glare of the sun is hiding it. But Saturn will begin to move out of the sun's glare during the month of March, and come later on in the spring and the summer, you will be able to enjoy Saturn once again in our summertime and early fall skies in the southern part of the sky soon after sunset. So if you have a telescope, that is the time to look for Saturn. That'll be the time to try to view its beautiful ring system. But again, number 2 on the list, the rings of Saturn. Here's something that's not in the same view as the sun right now. In fact, it's pretty much away from the rays of the sun and are quite visible in our wintertime sky. This is a constellation, the constellation we call Orion the Hunter. No other constellation can compare with it, really, in our sky. Orion looks like a huge box with 3 stars in the center, and another three hanging down from the middle or the left-hand side of that trio. The belt of Orion is the trio. The sword of Orion is that group coming down. And can you see the red glow over here? The gleam of Orion's sword, the great Orion Nebula. Right there is a cloud of gas. A cloud of gas is there in a region dominated not only by the brilliant stars that we see, but by gas. Here is the great nebula. And what a wondrous thing this is. Beautiful to behold. When you look through the telescope, you don't see this red. You actually see kind of a greenish gray, basically. But all the photographs show this beautiful red and blue and multicolored face of this cloud of gas so large it would take 26 years to go from one side of it to the other, traveling 11 million miles every minute of those 26 years. And it's not just a cloud of gas. You look at it and you say, oh, Joe, that's nice. A pretty cloud of gas. Well, big deal. But it's not just a cloud of gas. Here we see a photograph that was taken into that cloud. The year was 1947. William Harrow, George Herbig, using the big telescope out in California, the big 200-inch Palomar telescope, checking out the great Orion Nebula, checking around and looking and seeing these three bright knots of gas. And that's the way it appeared in 1947. 7 years later, in 1954, same astronomers, same instrument, same type of film, looking at the very same patch in the sky. But look what has happened. The upper patch and the one down to the right have doubled. Two stars born in that cloud of gas during the lifetime of some of you who are watching this presentation right now. And other similar gaseous regions are now either in this cloud or in other similar nebular clouds out in space. So, not just a pretty cloud. These clouds are the incubators of stars. New stars being born right before us. Stars that will blow away the excess gas until they fully radiate all of their energy. Stars that will shine in tomorrow's skies for future generations. Yes, magnificence and excitement in the region of Orion, and the gas and the dust and the strange grotesque shape like the horse head, so near the junction of the sword with the belt of Orion. Dust concealing gas beyond. That's not a cutout of what you see in the gaseous cloud here. This is a cloud of dust, and the dust is so thickly compact that we cannot see the gas that lies beyond. And it's in the shape of a horse head, kind of like what you'd find on a chessboard almost, so to speak. And other objects like this are all over our nighttime sky. Yes, Orion, the mighty hunter, who is now high in the southern sky during these cold winter nights. Orion, the mighty hunter, certainly entitled to be included on the list of the 7 wonders of the universe. Number 4 is our Milky Way itself. I hope that all of you who are watching right now have had a chance at least once in your life to see it. The Milky Way is our galaxy, and it appears in the sky as a beautiful, hazy band of light that stretches across the sky. From where I live, here in Putnam Valley, New York, 50 years ago, it was so obvious. It looked like somebody had taken an awl and scratched it into the backdrop of the nighttime sky. Because 50 years ago, here in Putnam County, New York, the skies were jet black. Not anymore, because the wonderful lights of man, and who would complain about them, nevertheless have now taken away some of the vistas that we once had as we looked out into space with the unaided eye. But when we're at sea, or when we're on islands far from most of the habitation of man, or when we're high, high up on a mountaintop, then we get a chance to see that beautiful glow as it arches across our sky. Starlight it is, stars beyond our ability to count, light, combined light coming from literally billions of stars, literally dozens of billions of stars, literally hundreds of billions of stars, combined light coming toward us. For our galaxy, our island universe, our home in the universe is right here in this Milky Way, as the artist has drawn it, a flat, spiraling disk of clouds, of stars, of gas, of dust, with its companion galaxies, the Magellanic Cloud seen in the skies deep down to the south, and the great clusters of stars strewn around it like lighthouses. A top view and a side view of our home. We are located over there. You see that circle in this side view, that circle over there, or the circle here in the top view? That is where our solar system, is located in our galaxy, about 2/3 of the way from the center to the far edge of the main part of the Milky Way galaxy, not including the halo that extends far, far beyond that which is shown. And the galaxy itself, shaped like two dinner plates, one upside down atop the other, with the great cloud of dark dust lying in between. Yes, this galaxy, our Milky Way, and again, every star that our eyes can see as we look up into the nighttime sky is part of that Milky Way. The glow itself contains the bulk of the stars, but we're embedded in it. And no matter in what direction we're looking, we see neighbors to our sun, other stars in our particular region of the Milky Way. As the fifth of the wonders of the universe, a part of the Milky Way, the great globular collection of stars that are seen in the same area as the stars of the constellation Hercules. Look at this, a ball of stars. There could be as many as 100,000 stars packed inside of this ball that you see here. Can you imagine what it might be like to live on a planet, a hypothetical planet of a star that happens to be near the center of that ball of stars? Because this globular cluster is not shaped like the galaxy. As I said, the globular clusters are strewn about the center of our galaxy, and they behave indeed, as I said, like lighthouses around the Milky Way galaxy itself. Magnificent objects, and objects that I think will be continued to study sorry about that, intently, my tongue got stuck, intently during the coming years ahead. For here is a question: what happens to stars when they're so closely packed together? What goes on within them? What motions take place deep within the heart of a globular cluster? For they're not flat spirals like the galaxies themselves, but as you just saw, they're more like globes of stars in the sky. And the stars must be moving, and they must be wandering. Are they colliding? Can we ever see the results of stellar collisions? Can we get spicules of energy bursting forth suddenly when stars crash and annihilate each other? What is the story of matter within these globular clusters? The globular cluster in Hercules is a summertime object. If it's June or July or August, and you're in a nice dark area where you can see the constellation we call Hercules, which in some astronomy books looks like a big letter H. In other astronomy books, it looks like, well, it's a quadrilateral, which is called the keystone. And right there at the top of that quadrilateral, if you have a pair of binoculars, you'll be able to see the great Hercules cluster. A small telescope will actually be able to resolve individual stars on the outer edge of the cluster. And if you have access to an observatory type telescope, a big telescope, maybe 12 or 16 or 18 inches in diameter, if you ever look at the Hercules cluster through a telescope like that, you will see literally what appears to be a fireworks display, a chrysanthemum of stars exploding from out of this central section here. Again, this great globe or ball of stars. And again, the Hercules cluster happens to be just one of many. One of the brighter ones, but just one of many of these star clusters in our galaxy. An amazing configuration of stars, and number 5 on my list of the 7 wonders of the universe. And now we come to number 6 on our list, the Crab Nebula. Oh, here is stardust. Now let me set you backwards in time. The date is, appropriately enough, July 4th in the year 1054 AD. Astronomers in China and among the American Indians in the desert Southwest as well, looking into the nighttime sky, looking into the eastern sky before sunrise, seeing a lovely crescent moon hanging low in the east-northeast sky. And then suddenly, incredibly, out of nowhere, a star suddenly appears next to the moon. But what an amazing star this was, shining forth, getting brighter and brighter and brighter, until soon, in a matter of days, it became so bright that it could be seen even through the brilliance of the blue daytime sky. For 2 months, it shone forth and then began to fade. For 2 years, it was visible in the sky, and then it disappeared. Fortunately, the men who observed it those many, many centuries ago carefully noted the position of it in the sky. And you could see here on a wall in the southwestern deserts, there's the supernova, there's the star, there's the crescent moon. And my presumption is that the person who did this on that wall, that is his handprint there. But from this, we were able to deduce the location of that brilliant guest star in the sky. Now, today, when we look toward the location of that star or where that star was with our telescopes, we see this stardust, tentacles of incandescent gas streaming outward, as it were, outward at speeds of 800 to 1,000 miles per second, streaming out in all directions from the location of where a star had blown itself apart. What a catastrophic explosion that must have been. Nova, said the men of old, new star. But no new star that. No. You know what that was? That was a dying star. And in the throes of death, the star blew itself apart, suddenly becoming literally tens of billions of times brighter than it ever had been. And there it is in our sky now, this stardust. And right in the middle of it, right here, is one little tiny star-like object. What could it be? Well, for a good long time, we looked at it and we said, well, it looks like a pretty little star. That's what we thought for a while. But then when the radio telescopes came to be, we found to our amazement that we were getting strange pulsations of energy from it. Actually, the whole thing started right here in the United States when radio astronomers from Yale, looking into the evening sky, even as do you and I, saw the stars twinkling beautifully. Oh, they said, the stars are twinkling. Now we know why they're twinkling. They're twinkling because of the atmosphere. Those little beams of light that come from a star, as they head for your eye, they move through our turbulent atmosphere, and that turbulence shakes those light beams in such a way that The star, when we look up into the sky at it, appears to scintillate, to twinkle. It's because of our atmosphere that we came up with that poem, Twinkle, Twinkle, Little Star. When the star twinkles violently, we know the atmosphere above our heads is unusually unstable. We wait for those nights when there isn't such instability, kind of the hazy night when the light beams come to us almost straight and true. But on those nights, many nights, they come through the atmosphere and get shook up, so to speak, by the turbulent atmosphere, and they appear to make the star twinkle. So the radio astronomers said, I wonder, said they, and that's always the very important question. I wonder, said they, whether or not the atmosphere causes twinkling in radio waves that come to us from space. Well, unfortunately, back in the 1960s, there were no radio telescopes on Earth sensitive enough to be able to pick up any such twinkling. But over in Europe, in 1967, Anthony Hewish and Jocelyn Bell had just completed work on their radio telescope, and they had sensitized it. That is, reduced the background electronic noise so that they were able to hear in their radio telescope fainter and fainter sources of radio energy. So they're exploring the sky with their radio telescope, and one night they turned it on the Crab Nebula. And you know what happened? As soon as they turned on the Crab Nebula and started to listen, they found these pulsations. Bing, 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 bing. Little pulses of radio energy. Pulsar, they called it. And now there are hundreds of them known today. This was the first, however, in the Crab Nebula. But then again, the men of the space age, when they sent satellites into space to investigate objects that had infrared radiation, and they turned it toward the Crab Nebula, guess what? In infrared, they found bing, 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 pulsations of energy, radio energy, in the infrared part of the spectrum. X-ray radiation was next, out in space. Bing, 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 bing. Again, pulsing from the Crab Nebula. All the forms of radiation pulsating from that star. Does light also pulsate? Well, persistence of vision does not allow us to see pulses that rapid when we're looking through the telescope. But this remarkable series of photographs that you see here clearly demonstrates. Look at the first photograph. Here's a bright star, and there's a little star to the lower right of it, right? Then we have the next frame showing the same star, but now that little star to the lower right is a little bit brighter. And now it is noticeably brighter. And now look at this. In the fourth frame, that star is now equal to the other star. And then just as quickly, that star in the lower right begins to fade, disappears. And then look at this. It flares back into view and then flares out. And it does this 30 times a second. The light energy pulsating from that amazing little star. We call that a neutron star. A star almost dead, spinning violently, and only a few miles in diameter. The core of what was once a huge star, a star that may have been 10 or even 20 times the size of our sun, now suddenly has been reduced to a star only a few miles across. And yet, all of the gas, all of the matter, all of the material that was involved with that star, and it was 20 times the size of the sun, has now, in the aftermath of the stellar explosion, been squeezed, compacted, pressed together into a body only a few miles across. And we know now that if it were possible to take a teaspoon of that gas and bring it to our planet Earth, that teaspoon of gas, because of all of that compression, would weigh literally hundreds, yea, thousands of tons. Gas. An incredible object, a fantastic object seen in the middle of that field of stardust called the Crab Nebula. Yes, indeed. Certainly ranking somewhere on the list of our 7 wonders of the universe. And now we've come to the end. We've come to number 7. And that is a neighbor of ours. Hi, neighbor. I almost sound like Mr. Rogers, don't I? But that is a neighbor galaxy of ours. That is the great Andromeda Galaxy. And that is you say to yourself, well, how far away is that galaxy? How many miles away is it? You don't say how many miles when you're talking about galactic distances. And this object, by the way, is among the closest galaxies relative to our planet. Here you see it, a photograph, a modern photograph. Edwin Hubble. That name may sound familiar to you. You've heard of the Hubble Space Telescope. We named that telescope after Edwin Hubble because Edwin Hubble was the first one to take a photograph of the galaxy in 1923 and resolve it into stars. Before 1923, we thought this was a cloud of gas. But thanks to Edwin Hubble, we now know that it's not a gas cloud, but rather it is a city of stars, very similar to our own. It's another galaxy out in space. So Edwin Hubble was the first to break this down or break this up into separate stars. Now, how far away, you may ask, is the Andromeda Galaxy? For that, let me show you a $1 million bill. Now, there is no such thing as a $1 million bill. Certainly no such thing as a $1 million bill that's in free circulation. But let's pretend for a moment that tomorrow on your way to work and school, you look down, you find a $1 million bill. Pick it up, put it in your pocket. Congratulations. You are now a millionaire. But if you wanted to be a trillionaire, you would need 1 million of those $1 million bills, because that's what a trillion is. 1 million times 1 million. You know, we hear in the news about funding, about various bills that are put forward in Congress, which total X number of trillions of dollars. You cannot imagine, even for a moment, what a trillion really is. I told you it was 1 million times 1 million, but really, how do you envision a trillion? I mention this to you because when we talk about stellar distances, like for example, light year, you've heard of objects that are, let's say, 10 light years or 100 or 1,000 light years away. What is a light year? A light year is the distance that a beam of light has traveled in one single year. So if you were to take a powerful, let's say, beam of light, like for example, the beams that represent the Twin Towers on 9/11, we turn those on and the beams go straight up into space. Well, how far up do they go? Well, those beams, those light beams, if you can imagine, go straight up, straight out, and the light rays go all the way out, traveling at 186,000 miles per second, 11 million miles a minute in 1 year. The light from those light beams have traveled 6 trillion miles. That's 1 light year. 6 trillion, a little less than 6 trillion actually, but we'll round it off. And now you know why astronomers use light years instead of miles. The nearest star is Alpha Centauri. That's 25 trillion miles away. That's 25 with 12 zeros after it. And if you start quoting miles instead of light years, instead of saying 25 trillion, why just say just 4.3? That's how far away it is in light years, that closest star. The Andromeda Galaxy is 2.5 million light years away. So if you want to know how many miles away that galaxy is, just simply multiply 6 trillion by 2.5 million, and you'll come up with an answer that will give you 15 with 17 zeros after it. That's how far away the galaxy, the Andromeda Galaxy is, and that's just among the closer ones. There are some galaxies that we've seen that are 10 million, 20 million, 60 million light years away. And the farthest object, the most distant objects, are quasars that are 13.8 billion light years away. That may be the edge of our known universe. You can see that it's much better to simply use light years as opposed to putting all those zeros down. If you did that, you'd fill an astronomy book up. They filled many pages up with all those zeros. There you see the center, the core of the Andromeda Galaxy right there. And let me tell you, the Andromeda Galaxy is about double the size of our own galaxy. Our galaxy contains about 400 billion stars. Our best estimate or guesstimate for the Andromeda Galaxy is about 1,000 billion, or if you will, 1,000 billion, or perhaps 1 trillion, if you want to round everything off, 1 trillion stars in the Andromeda Galaxy. And they say, why can't we talk to somebody on the Andromeda Galaxy? Well, the reason is simple. Light travels at the speed of light. So if we were to send a radio signal to the Andromeda Galaxy, keep in mind it wouldn't get to the galaxy for 2.5 million years. And then we'd have to wait another 2.5 million for a response. So we are effectively quarantined. We effectively have no way of contacting anyone in that galaxy, although that galaxy must be teeming with planets. And people who live on planets in the Andromeda Galaxy are probably looking back at our own galaxy and saying the same thing. I wonder if there's anybody in that galaxy, any life forms that might be looking back at us. Kind of an amazing thing, isn't it? But anyway, that is number 7 on our list of 7 wonders of the universe, the great Andromeda Galaxy. And so we have seen the 7. Like the 7 wonders of the ancient world, they shine forth in the sky. But unlike the 7 wonders of the ancient world, they remain on and on and on and on. For you see, of the 7 wonders that once graced the surface of our planet, only one remains: the pyramids and the Sphinx of Egypt. That is the last of the 7 wonders of the ancient world that is still in existence to this very day. But no more can we find the hanging gardens of Babylon, which once were so magnificent. No more can we find the great giant golden statue of the god Zeus, for it's gone forever. No longer can we find the beautiful temple built in honor of the goddess Diana, destroyed, ruined by the ravages of time and man. Gone forever, the tomb of King Mausolus, from which we get our name Mausoleum. Gone forever, the mighty Colossus of Rhodes, no more to be seen. Gone forever, the 7th of the 7 wonders of the universe, the great lighthouse of Alexandria. Yes, the artifacts of man were created, magnificent though they may be, but temporal they. But the wonders of the universe, they remain. The face of the moon, the rings of Saturn, the constellation Orion, the great Milky Way galaxy, the great globular collection of stars located in the constellation of Hercules, the great globular cluster, the Crab Nebula, and the galaxy that is located beyond the stars of the constellation Andromeda. Yes, my friends, ladies and gentlemen, these are the 7 that have been selected as the 7 wonders of the universe. And that is the end of the talk. And I thank you. And now, if you have any questions, I'm looking on the chat board here. Man went to the moon and played golf. Yes, Alan Shepard was the one who smuggled a golf club on his trip to the moon, his journey to the moon, Apollo 14. Let me also point out that Alan Shepard was the first American to be launched into space. Let me point out that Alan Shepard was among those in the Apollo program that advanced our technology. Every time you play on your computer, every time that you look at your big, giant, flat screen TV, every time that you pull out your iPhone, your smartphone, Every time that you partake in any modern technological instrument that we have today, remember where it all went back to. It went back to the space age. It went back to the Mercury, the Gemini, and Apollo programs. And it was back to the men who risked their life, like Alan Shepard, to go into space, to land on the moon, to bring back specimens from the moon, rocks from the moon for us to study. I think that all of the riches that we have gleaned from all of that technology in the past 10, 20, 30, 40, 50 years, we all owe it to the space program. People say, why did we go into space? Why did we go to the moon? What did we need a space program for? Well, there you have it, folks. You could not exist today. I know people today who have a fit if their iPhone doesn't work. They go and have conniptions if something happens to their PC or their MacBook Pro or whatever. You cannot live in today's world with the technology that we now have, and it couldn't have existed without the space age and men like Alan Shepard who walked on the moon. So to me, I say, go ahead, Alan, hit a couple of golf balls. After all that you went through and all the people who worked to put you there, you deserve that little few moments of fun on the lunar surface by hitting a golf ball or two back in I think it was 71 when Alan Shepard went to the moon. Fun movie regarding radio telescopes, Contact, yes, with Jodie Foster and Matthew McConaughey, based on a novel, I might add, that was written. The name of the novel was Contact by the late, great Carl Sagan. In fact, you see at the end of the movie a tribute to Carl. It said this movie is dedicated for Carl. And his novel was made into the movie, again, with Jodie Foster and Matthew McConaughey. A great movie. I use the phrase the known universe. Do I believe that there are other universes out there? Well, you see, we live in our galaxy. We call it an island universe. An island universe, but that doesn't make any sense because universe means encompassing everything that is known. And yet we know that there are other galaxies out there, other island universes. So it's not just us and it's not just our Milky Way galaxy. There are other galaxies, other universes, if you will, that are scattered all over, far too many to even count. And again, it boggles the mind when you kind of wonder how many others civilizations might be living on planets in galaxies that we have looked at and have discovered in our telescopes. So it's amazing. It is, and as one of my mentors in astronomy, the late Fred Hess, who used to lecture for many years at the Hayden Planetarium, used to say, the universe is your universe. It is yours to behold and yours to enjoy. It's so sad that today, 4 out of 5 people have never seen the Milky Way because the lights are so bright. If you have an opportunity on your summertime break to take a vacation, a camping trip away from the bright lights and to see the sky and the Milky Way and the nighttime heavens the way they truly should be seen, do it, because again, we have lost so much, especially in the last 50 years, because of the buildup of bright lights here in our metropolitan areas and in metropolitan areas all over the United States.
Well, Joe, thank you very much. I mean, does anybody else have any more questions for Joe tonight? But if not, that was extremely informative. We really appreciate you taking time out of your busy schedule to speak to the community here at Pearl River. As a reminder, this lecture was recorded. I will be sharing it with the patrons either tonight or tomorrow. We'll get you out the recording, and especially for those who have missed it as well. We are on Facebook Live as well, but we really do appreciate you taking the time. That was very informative. We just really appreciate it so much to have you here tonight. It was fantastic. Let's see. It looks like we do have a Q&A. Excellent presentation. Love your enthusiasm. That's exactly. I mean, just the enthusiasm, and I'm going to finish reading, and passion. Keep looking up. That was
Well,
by John.
I will say one thing. I mentioned him in the talk, Fred Hess. As you mentioned, I give lectures. I'm part of the community at the Hayden Planetarium. Fred Hess was an amazing guy. And whereas all the rest of us on staff, when we gave presentations, at the end of our presentations, people gave us a polite round of applause. Whenever Fred gave a talk, Fred, people would almost give him a standing ovation. And I finally asked him, I said, Fred, what is it? How do you end up getting such a pop, whereas the rest of us just get a polite little round? What's your secret, Fred? Tell me. Please tell me. And Fred looked at me and he said, Joe, he said, the secret is never, ever lecture. Never lecture. If you lecture, you're going to put people to sleep. He said, the secret is tell a story. Tell a story. The best teachers are the best storytellers. If you can tell a story, you'll have your audience riveted, and they will be listening to you, and they'll never fall asleep. And I remembered that. And ever since he told me that was over 30 years ago, I've been giving my talks in the Hessian way of giving it. This is what you saw was basically, I shamelessly copied Fred's methodology and have used it successfully in all of my presentations. And the note on the chat board here, please come back. I don't know if you got my latest program prospectus, Michael. I just sent this out about a week ago. All the programs I'm doing for the spring and summer. If you haven't, I'll gladly send it to you again. And a lot of people are signing on for other talks that I give in weather and astronomy. 2 of them, in fact, in the month of May. We're going to have a total eclipse of the moon on the night of May 15th. And at the end of the month, I wrote a technical paper, research paper on a possible shower of meteors, a brand new, never before seen meteor shower that will appear in our sky late on the night of May 30th. And on that night, if everything falls into play, you may see more shooting stars on that one night than you have in your entire lifetime. I call that program the Night of the Shooting Stars. So those are just 2 of the programs I'm offering, and libraries have been signing on to that. So if Pearl River's interested in me coming back to talk about those events, be happy to talk about those or any other event in meteorology or astronomy. I am your obedient servant, and we'll be very happy to come back.
Oh, absolutely. I will definitely shoot you an email after this program about that. That sounds amazing. But yeah, excellent. Once again, please come back. Just to repeat what you said, and absolutely, we'd love to have you back. We had a great turnout tonight. We had great amount of people sign up, a lot of interest. So, these are definitely different programs that we love to put on, and we love to put them on for you, the patrons. Without you and your support, we wouldn't have great people like Mr. Rayo here this evening. And we really appreciate the support here at Pearl River of our patrons, but also of our presenters and our storytellers. Absolutely. So
yes.
we do appreciate it, and we will definitely be in contact soon. And I will definitely share the video of tonight's storytelling of the sky of the 7 wonders. So we do appreciate it. And I just want to wish everybody a great night, and thank you very much for coming out and spending this time with us. And wish everybody have a good night. All right.
Thank you, and have a good night to all of you. And maybe we'll see you soon. We'll be back.